What up, algebra squids? Welcome to lesson 7.3 or 7-3, whatever floats your boat, however you want to call this. But this is called negative exponents, and it also has the exponent of 0. I briefly talked about negative exponents and to certain students, exponent of 0. So it should kind of make a little bit of sense. I'm going to try to ease it in with as much as possible, but it's a very simple concept. Remember that there's two things in math. There's pretty much me showing you just the way to do it, right? Just see how it's done and do it, and that's it. But then there's also the explanation part, right? What's happening behind the scenes. It's like a magic trick, right? I can either show you the magic trick, or I can show you like what you actually have to do to get the magic trick to work, so you can do it yourself. So from the book, straight from the book, learn the 0 exponent. Key concept, 0 exponent property. Any non-zero number raised to the 0 power is equal to 1. Once again, any number that is not 0 raised to the 0 power is equal to 1. Guys, any number in the world. Go ahead and grab your calculator and put the craziest number. You can put the craziest decimal, whatever you want to put. Then go ahead and tell your calculator that you want to put an exponent of 0. So you click this right here on your calculator, and then you click the number 0 in your calculator, because you're telling your calculator that you're going to put something to the number 0. So even if you wanted to put the number 7 trillion, even though you can't put that in your calculator, 7 trillion to the power of 0, or negative 4.23 to the power of 0, all of that will become 1. It will just become 1. Okay? That is the simple property of the power of 0. Okay? The one that I will be able to give you a little bit more feedback on would be the negative one. So when we get to that one, I'll give you a little bit more reasoning as to how things happen the way they happen. So let's look at this first example. Example number 1. Simplify each expression. Assume that no denominator equals 0. Well, the reason why this is written here for us, assuming that... Hello. Mic check. There we go. Sorry, just dropped the mic. Drop the mic. Let me see. All right, everything's good to go. So the reason that's written for us is so you understand that the problem just doesn't go away, because obviously if you had a denominator of 0, then it's kind of not worth doing the problem, because anything divided by 0 is always going to be 0. But for A, if you look at A, it's so funny because there's so much in there. There's so much inside of this problem. But the truth is that what's going to happen is we're just simply going to distribute this power into everything inside. Everything is going to get a power of 0, even if it already had an exponent. That means we have a power to a power. Now, what's going to happen here? We have this negative fraction, which is 8 to now the power of 0. Remember that power to a power? What is power to a power? Power to a power means m already has an exponent of 2. It already has an exponent of 2. We can see it. And then it is being raised once again to the power of 0. Power to a power, when that happens, an exponent raised to another exponent, you multiply. So 2 times 0, or anything times 0, is just 0. N has a power of 1. We don't see it, but we know it's an implied power of 1. So 1 times 0 is 0. You can see where this trend is taking us. Everything here will become an exponent, or we'll have an exponent of 0, because that is what we just distributed to everything inside. Now, this entire step, what I just did, is kind of silly to write out, because the truth is that everything to the power of 0, everything turns into a 1. Okay. So what is this going to look like? It's going to look like a 1. So the 8 to the power of 0 becomes 1. The m to the power of 0 becomes 1. The n to the power of 0 becomes 1. The p to the power of 0 becomes 1. Divided by 9 to the power of 0 comes 1. K to the power of 0 comes 1. M to the power of 0, 1. n to the power. Whoa, that was the most disgusting one I've ever written. Excuse thy one. And there we go. So what do you think is going to happen here? What is going to be your solution? Well, our solution here is pretty much 1. 1. Just 1. Now, one question that somebody might have, which I just remembered, would be this. There's a negative in front of here. Don't we just carry that over to our final answer here, so solution? And the question is this. I want you to grab your calculator and enter the information exactly in the order that I'm about to tell you. So what I want you to put in your calculator is I want you to put the number negative, I don't know, 3. Whatever negative number you want, whatever negative number. Now, after you press -3, you need to tell your calculator that you're going to give it a different exponent. And after that, after you click that, you press 0. After you click 0, press enter, or what is that equal to? And that is going to give you 1. Any number, whether it's a positive or a negative number, you will get a solution back of 1. Okay, so that is why that 0, I'm sorry, not 0. That is why this negative is not brought to our final answer. That negative is within the parentheses. If there was a negative outside of the parentheses, then yes, then you do apply that negative afterwards. All right, but that negative was inside of these parentheses walls. So let's see if you can do B on your own. Pause it right now and try B. Let's see if you can get it. Yo, $20, you got this one wrong. $20, you got this one wrong. What is this going to give us? Well, a to the 4th power and a to the 2nd power have nothing to do with 0. Please remember that a has a power of 4 and the a here in the denominator has a power of 2. They have nothing to do with the power or exponent of 0. The only one being affected here by the power of 0 is b. Only one, the only one, the only one, the only one. Please do not give that exponent or change anybody because of that exponent of 0 other than the variable b. So this will turn into a 1. So what we pretty much have is a to the 4th times 1, which once again, I'm just going to do this right now because these are example problems, but these ones, we can just kind of cross them out. We can say they go, they just go away. We don't really care about a multiplication by 1. And then what we have here, don't forget now, we have the quotient rule of exponents. We have 4 a's on the top, 2 a's on the bottom. What do we do when we have division property with exponents? 2 of them, the 2 a's that are on the bottom will cancel with 2 of the ones that are on the top. So that is going to leave us with just 2 a's on the numerator, or as whole number, you can call it, or yeah, we'll call it numerator. That's it. This is our final answer. So even though we just learned that the zero exponent rule makes everything a 1, this solution right here did not become a 1 because the 0 exponent was not applied to everything. It was just applied to that piece, that variable b. All right. All right, here we go. Check problem. Do it on your own. Try it out. All right, so even though it says select the simplified form of this division here, this fraction, we don't have multiple choice because we wiped it out. You're working on a piece of paper. Assume that the denominator does not equal 0. Once again, we're just assuming that we will get some other answer other than 0. That way we can actually work with the problem. Oh, look, this looks like a face. Sorry, my ADHD is kicking in. So what do we do here? Well, we do everything we kind of know what to do with. I'm gonna first write everything down. That's what I'm gonna do. I'm gonna just write it down so I have it all here and I can start making some changes and marks to it. G to the 0, H to the 0, J to the 0 power. Okay, so the first thing I'm gonna think about is I'm going to think about 56 divided by 8. That's the first thing I'm going to think about. 56 divided by 8. Think about it as a regular fraction. What is 56 divided by 8? Or what number do you multiply 8 by to get 56? That number should give you 7. All right, so 7 times 8 will give you 56. Now, that is going to stay in your final answer. So just write it down. Whoa. 7. And remember that this is a 7, not a 1/7. So a 7 means that it's going to be in our numerator, our top. All right, so what goes next? I'm going to go ahead and cross out 56 and 8 because that's pretty much what I took care of. I can see that I have G's on the top and G's on the bottom, but the truth is that the G's to the 0 power, the H to the 0 power, and the J to the 0 power, they just turn into a 1 or multiplication by 1. So that turns into a 1, right? That turns into a 1 and that turns into a 1. Pretty much all you have in the denominator is just the ones being multiplied. Remember, 1 times 1 times 1 times 1 times 1, as many times as you want to do that, it's just equal to 1. And when we have a denominator of 1, we don't really have to see it, okay? So don't write it down. It's not needed. We're trying to write this as simplified as possible, so we don't write those ones. We still have those G's on this to the second power alive. They didn't go anywhere. They didn't cancel with anything. H didn't cancel with anything either because the H is down here, turned into a 1. And then J to the 11th power just stayed as J to the 11th power, okay? That's it. So just leave it like that and nothing cancels, even though some people, because of what we learned last lesson, you might think that we got G's on the top, we got G's on the bottom. You might think that these might cancel, but no. Remember that these just turn into a 1. Simple idea. All right. Let's now talk about negative exponents. How do we treat negative exponents? Well, you can go ahead and read everything you want here. Take your time, read it, pause it at your own pace. Pretty much, I'm going to read these last few bullet points that we have down here because it's very crucial and very important to understand. A lot of the time students get the problem wrong, not because they don't know how to do it, but because they don't fully simplify the problem. They do certain steps and then they go, oh yeah, I forgot to divide the numbers. Number 1, a fully simplified expression will only contain positive exponents. Only positive exponents. So if you have an answer that has a negative exponents, you are not done with your work. Remember that. Bullet point number 2, each base appears exactly once. Each base appears exactly once. So if you have an answer that looks like this, a to the 3rd power times a to the 7th power, and that's your answer, that's not simplified. This should equal to a to the 10th power, okay? That's what it means. Your base was your a in that example. The third one, there are no powers of powers. Powers of powers is an exponent raised to another exponent. So if you have a solution or you think that your answer is something that looks like this and you have an exponent raised to another exponent, you are not done. Your final solution would be 2 times 3 is 6, okay? So these are all the little things that students would miss thinking, oh yeah, that's it, I'm done, I simplified it. No, there should not be an exponent raised to another exponent. Then the last one, all fractions are in simplest form. Fractions, simplest form. All those numbers, grab your numbers and simplify them as you would a regular fraction. Now, let me go back up here really quick and explain to you what we do to get rid of negative exponents so we can have all positive exponents. But Mr. C, what do I do if I have a x to the negative 3rd power, right? What do I do if I have an x to the negative 3rd power? Well, let's do something really quick, and I hope you do follow me with your calculator. Grab your calculator right now and follow everything that I'm about to tell you, because I'm going to do it in my calculator as well. These numbers might be a little bit weird, but let's do a thing. Let me go to a blank page. So what I want you to do is I am going to tell you to grab the number, let's do the number 3, and we're going to take it to the negative 4th power. Okay, that's what we're going to do. So how do we do that in the calculator? In the calculator, you're going to type the number 3 first. Then you're going to type, hey, calculator, give me a new exponent. And then you're going to type the number 4. Remember that these calculators that we're using, the TI, Texas Instruments 30XA, you have to write the number or type the number first and then type the negative. All right. Then you should click equals or enter, right? So let's see what I get with this. I get 3 raised to the 4, which is negative power, equals. This is what I get. 0.0 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's beautiful. I didn't plan that. Let me make sure I didn't do anything stupid. 3 to the 4th, which is negative power. 0. Okay, cool. Yeah, 2, 3, 4, 5, 6, 7. All right, and the reason why it goes from a 7 to a 9 is because remember that your calculator screen stops right there, and it pretty much just rounded. It rounded that number. So don't forget that it should have, following the pattern, should have been an 8, right? So what I want you to do is say, okay, well, that is the answer. What are you trying to show me with this? What I'm trying to show you is the little thing that we do to get an exponent to be positive. What we do to make an exponent to be positive is we just take it to the other side of the fraction. Just think of a fraction as the top and the bottom. Simple as that, just top or the bottom. Now, the number that I gave you right here is just the number 3, the base. Just look at the 3, it's a base. You can think of the 3 as a whole number, meaning it's a numerator, it's a top number. Now, what happens if I actually were to give you that 3 at the bottom of an, right, at the denominator, as a denominator? So what I did is I grabbed the 3 that was up here and I took it to the bottom because it had a negative exponent. Mr. C, you forgot to put the negative with the 4. No, I didn't forget to put the negative with the 4. When you take a value with its negative exponent to the opposite side of the fraction, it doesn't only have to be to the bottom, but you can also take it to the top if it was already on the bottom as a negative. We'll do more examples, don't worry. So when you take it to the other side of the fraction, you switch the exponent. You can switch. I'm sorry, it's not you can. You have to switch the exponent from a positive to a negative. Now, the way that I can prove this to you is if you now grab your calculator and you do 1, right? Well, this is what we're going to do. We're going to do 1 divided by 3 to the 4th power. So in your calculator, if you type 1 and then you type divide by, and then you type 3 to the 4th power, right? Positive 4 this time. So 1 divided by 3 to the 4th power. And look at your calculator. You will get the same exact thing as this. Okay, so hopefully I don't have to keep doing this. You can do this little exercise if you want to keep proving it to yourself over and over again. But what I'm trying to say is all you got to do to get a negative exponent to become positive is just take it to the other side of the fraction. If it was on the top, take it to the bottom. If it was on the bottom, take it to the top. Take it to the top. Take it to the bottom. Yay, yay. All right, let's look at example number 2 so you can see exactly what I'm talking about. Simplify this thing over here and assuming that the denominator is not 0, so we can obviously do the problem and it's not wasted. So a to the 3rd power. Do you see the 3rd power? Does it have a negative? It does not have a negative. There's nothing going on here. Now, the b has a negative 4th power, right? C has a negative power of 2. So what we do here is we actually just swap their places. B will be taken to the denominator. Look at A. We don't move A because A already has a pretty simplified, when we say simplified, it just means that it's a positive exponent. And now B needs to be moved to the bottom. B needs to be taken down. So B is going to now have a positive exponent of 4, and then C needs to be taken to the top, right? Because C has a negative exponent. Oh, I was about to write -2. That's it. This right here is the answer. You just learned everything you needed to learn. So pretty much, the 0 property, anything that's to the power of 0 turns into a 1. It doesn't matter how crazy complicated you think the number is. If it's to a power of 0, it'll become 1. And anything that has a negative exponent, just switch it to the opposite side of where it's at in the fraction, whether the top or the bottom. Go ahead and pause it right now and try this check problem. Go. All right. Let's go ahead and do this. I'm going to go ahead and, yeah, I'll rewrite it. 42 r to the negative second power, t to the negative 6, u to the third, all divided by 14, r to the second, u to the negative third. The first thing I'm going to do is I'm going to grab 42 and divide it by 14 because those are doable. Those are two even numbers. And 42 divided by 14 will give me 3. Whole number 3. Doesn't give me 1/3. Doesn't give me this. It gives me 3. So I keep my 3 in the top, the numerator. What I'm going to do next is I'm going to draw my my fraction line. And then in my fraction line, I decide to move things up or down. Okay? So don't worry about anything else other than moving things from up to down or down to up. So I want you to keep your eyes on the first one, the r to the negative second power right here. Negative exponent, right? Hopefully you agree with me. So that means we're going to take it to the bottom. Now, 42 and 14 have already been taken care of. The next thing I want to look at is pretty much you can go in whatever order your heart desires, but I'm going to try to keep it in a smart type of order. Like I just wrote the r to the second power right here, and I could see that there is another r to the second power that existed on the bottom, but it's a positive exponent. Since it's a positive exponent, you keep it on the bottom. Don't move it. The biggest mistake that students make in this lesson, for whatever reason, is that they start moving things. They go, oh yeah, just move everything. No. You only move the things that have a negative exponent. If it has a positive exponent, you leave it where it's at. They somehow have this misconception that positive exponents go to the top. Oh yeah, that r has a positive exponent, so take it to the top. No. Positive means stay. Negative means you move. So these two have been taken care of. I already wrote them down. Next one, t to the negative 6. That has a negative exponent, so it has to move. I have to move it down. And then once I move it, it becomes positive. Done. I see that I have no more variables with t, so I'm now going to go with u. This u right here is positive. U to the third power is positive, so it stays where it's at. But this one right here is negative, so it goes up. U to the third power. All right, cool. I just dealt with my negative exponents. The next thing that I have is just pretty much the same ideas of exponents that we've learned before, which is combine by the product, right? Product of the exponents here. We have 3 u's here and then 3 more. What is that going to give us? That's going to give us u to the, here's where you have to think about this. Do you add the 3's? Do you add your exponents, or do you multiply them? And this, by multiplication with the same base, we keep the base of u and we add the exponents. The only time where we multiply is when we have an power to a power, or an exponent raised to another exponent. All right, so once again, we have these r's right here that can combine just like these u's did. We keep the same base of r, and then we add the, I said add and I didn't even add it. And then we add their exponents. R to the 4th power. T has no other variable to pair up with, so we leave it as t to the 6th power. That's it. And that's it. Hopefully you can agree with me that this is cake. Example number 3. Let's see what we got. All right, so for this one, simplify an expression with negative exponents. All right. I do challenge you. See if you can pause it right now and try it on your own. All right, so we got 3g to the negative 3rd, h to the 2nd power, negative 36, g to the 3rd, h, j to the negative 4th. Okay. So little things to watch out for. Number 1, 3 over negative 36. All right, I want you to look at that for a second. So 3 divided by 36 negative, if you were to put that in your calculator, right? or just think about it for a second. What can you divide both of these by? Hopefully you understand that you can simplify this fraction so it could look like this. You can divide them both by 3, right? So it's going to be 1 because 3 divided by 3 is 1. And then to get to 36, you will need to multiply by 12. So this is what your fraction will look like. So that's exactly what we want to write right here. Just bring it with you. Simplify your numbers exactly how you would regular fractions. The next thing is, so let me go ahead and cross out the numbers that I took care of. The next thing I'm going to worry about is the g's. Now, that g to the negative 3 needs to go down because it's negative. G to the 3rd power is now positive. The ones that are right here are already positive, so they will stay with a positive exponent. I will not move them. So we now have h. Different color. The h that we have here are positive, so I will keep those h's at the top. Remember, when it's positive, you keep. When it's negative, you move. The h that you have down here, which is to a power of 1, or we don't see the exponent, stays. It's a power of 1. It's a positive exponent. And lastly, j to the negative 4th power moves up. J to the negative 4th power now becomes j to the positive 4th power. Okay. Now what can we do here? Remember, we need to simplify as much as possible. I do want to remind you that this 1 that we started off with in the numerator is multiplying with other things. And remember that when you multiply by 1, the 1 is pointless. So we can kind of just not use it, right? When continuing to write our answer. The next thing we think about is say, okay, well, remember that in the slide that we talked about, when is something fully simplified is when you don't have the thing or something that has the same base. So h, I see h at the top. Do I have any h's on the bottom? And I do have h's on the bottom. This 1h will cancel with one of the ones here, leaving me with 1h at the top. And remember, we had that 1 go away because we don't really care about that 1. J, do you see any other j's in the problem other than the numerator? And the answer is no. There are no more j's in the fraction. So that's pretty much going into our solution. The negative 12 stays as a negative 12. There is no other number to simplify this. G's, we have 3 g's and 3 more g's, and they're all multiplying. So this right here, when they are multiplying, we keep the same base, and all we do with the exponents is add them. We do not multiply, only multiply when you're doing a power raised to another power. All right. If you need a little more explanation on this, make sure you reach out to me. If not, replay it. Rewind this, play it at your own pace. All right, check problem. Freeze your screen, try it out. All right. I'm going to do this one a little bit faster. I'm going to show you how fast you can actually do these type of works, these type of problems, and finalizing your answer, right? So the first thing is, I'm just going to rewrite it. 35h to the 0, j to the negative 5, k to the negative 2, 14h to the 2nd, m to the 5th. The first thing I'm going to look at is the 35 and 4. 35 and 14, I mean. 35 and 14 cannot be reduced. That's a fraction that cannot be reduced or divided by the same number. If you look at 14 and you look at 35, they cannot be divided by the same number. They can only be divided by 1. So that means that I'm going to keep 35 and 14 in my answer. That's it. Treat it as a regular fraction. Since you can't simplify it, leave it as is. The next thing I'm going to have to say is that is to the power of 0. So it becomes 1. A 1 is irrelevant in multiplication. It will not affect my bottom h's here. These bottom h's, so I already took this into account. These bottom h's are have a positive exponent, which means they have to stay. They stay where they're at. That's simplified. We have j's, or you can whatever order you want to think about right now. But we'll go with let's go with the j. These j's up here have a negative exponent. So that means I need to carry them down. So we have j to the 5th power is now positive. I see that there aren't any more j's, so I'm not really worried about how that's going to change. M and k, these are 2 different letters. They're not going to affect each other, but I do see that k will have to be brought down from -2 to a +2. So took that into account. And then m to the 5th power, I see that the 5th power is positive, so it stays as a positive. So even though my fraction, my fraction right now kind of looks lopsided, this is it. This is what our final solution is going to be. What do you think? All right. Oh, wait. You know what I noticed? Ooh, did anybody catch this? Did anybody catch this? I just noticed. The 35 and 14. 5 times 7. 5 times 7 will give me 35. And 2 times 7. So I can divide this right here, 35 and 14. Oh, I can divide them both by 7s. Oh, Mr. C almost got this wrong. Okay, so this will give me 5/2. Okay. So let's change that. My numerator becomes 5. My denominator numerical value is 2. So h to the 2nd, j to the 5th. What do we got? K to the 2nd, and m to the 5th. I hope I wrote all of them right. If I made a mistake, just let me know. But yeah, careful. All right. So what I want you to do right now is take a second, and I want you to read this. Understand it yourself. Don't wait for me to read it. Understand it yourself, and then press play. Pause it now. All right. So order of magnitude is used to compare measures and to estimate and perform rough calculations. The order of magnitude of a quantity is the number rounded to the nearest power of 10. For example, the power of 10 closest to 105 million is 10 to the 8th power, or 100 million. So pretty much just take year 1 right here, right? And everything else behind it is just going to be 0, right? So yeah, apply example number 4, which is just real world work right here. The maximum speed of a peregrine. All right, let's call it a falcon. Is about 90 meters per second. The maximum speed of a snail is about 0.01 meters per second. How many orders of magnitude as fast as a peregrine, potato, falcon, is a garden snail? So remember that when you compare 2 numbers, you want to create a fraction. So these are the numbers that I always like to use. 5 and 10, right? 5 and 10. If you do 5 divided by 10, you're going to get half. That's because we're comparing 5 to 10. 5 is half. 5 is half of 10, right? But if we do it the other way, 10 divided by 5. So 10 compared to 5, this is 2, because 10 is twice as much as 5. So that is how you compare numbers. That is the same idea what we want to do right now with this information. But obviously we're doing with numbers that are kind of crazy, right? So they want us to know the if you read this last sentence a little bit slower, how many orders of magnitude as fast as a falcon is the snail? So we're pretty much saying, hey, the snail is this much compared to the falcon. So that will tell us to put the value of the snail, whatever order of magnitude the snail has, as the numerator, and then the falcon's magnitude in the denominator. So if you didn't get this far, pause it right now and go ahead and write what numbers do you think are the ones that would go right here. All right. The magnitude of a snail. Oof. Okay, so for the snail, what we have to do is actually go backwards. we have to go backwards so we get into a 1. How many times do we have to go backwards? 1, 2. We would have to move that decimal to the right 2 times. That is why we have a -2 right here. Okay. For the Falcon, what do we put for the Falcon? 90 meters per second. Well, how do we get that 90 to become the, whatchamacallit? The order of magnitude. 10 to the second power. 10 al segundo poder. Because remember, we're rounding it. 90, we're going to be rounding that to 100. So that means we would have to bring this decimal right here. 1, 2. It's going to be located right there. All right. So what do we got? Now that we have this right here, we're going to be using our properties of exponents, the division property, to get, and the negative exponent property to simplify this as much as we can. How do we do this? Well, we could see that the top order of magnitude for the snail is a negative value. So what we're going to do is we want to take this and bring it down to the bottom. Now, remember that when we take it down to the bottom, what we have left over, even though we don't see anything, we do have to put a 1 as a placeholder. We can't just put a 0 because remember, 0 will cause an impact that is not what we need, right? So the 10 to the second power of the Falcon that was already there will stay there. And now we're bringing down the other 10 to the second power. How do you do this? How do you calculate this? Well, the way that we calculate this is the same way that we would do with the variables. If these were variables, we keep the same base number of 10, and then our exponents will be adding together. So this is going to be 10 to the 4th power. So if you put this in your calculator, what is this going to be? 1 divided by 10 and then to the power of 4. We actually have our answer of 0.123, right? This right here is how fast a snail is compared to the Falcon. 1, 2, 3. Ooh, yeah, beautiful. All right, let's see if you got what it takes to get this check problem on your own. Try it out, pause it, think about it. Don't cheat. All right, let's see. Length. The radius of Earth is about 10 million meters. The radius of a virus, Jesus Christ, is about, okay, so really quick before we get to it, remember that a radius is the distance from the center of a circle to anywhere to the side of the circle, right? So it doesn't matter if you go from the center to the side with a black line edge through it, or this way or that way, it doesn't matter. They're all going to be the same distance because the center is always the same distance away from any side of the circle. All right, so the radius of the virus is about, I'm not even going to say that number, meter. Approximately how many orders of magnitude as long as the radius of a virus is the radius of Earth? Wow. So that's going to be a large number. So we're doing how much more is Earth, the radius of Earth compared to that of a virus. So using estimations, how many times greater is the radius of Earth than the radius of a virus? So what do we got here? Well, if we get these numbers, and we can see that to make this into how many zeros do we got here? 1, 2, 3, 4, 5, 6, 7. So that's the same thing as saying to the 7th power like that. And then the other one, how much is the other one? 1, 2, 3, 4, 5, 6. And then to get it into a 1, that'll give me 7 jumps, but it's to the right. So I am doing Earth compared to the virus. So this is 10 to the, and I went backwards. I needed to go that way to get this into a whole number. So -7. So this is what we're working with. What do we got here? We need to obviously take this right here to the top, which will be the 10 to the 7th power, which is already one from Earth, will be next to, by multiplication, to the one that of the virus, the one that was a negative. We took it up now. And the way that we deal with this is we keep the base the same as 10, 7, and 7, the two exponents we actually add. So we get 10 to the 14th power. Wow, that's how many times more. So we get 10 to the 14th power. What that means is that we need to have a very large number that has been taken. Let me see if it's this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We found it. So this is the large number that we would need, nothing else, because the other ones won't be large enough to equate to this much. Now, for the explanation, or the wording behind it, is the radius of the Earth is about, we have it right here, that much more. It's 14 orders of magnitude greater than the radius of a virus. All right. So I know that that was a little bit tricky because we just learned about what orders of magnitudes are and the radius of a circle, which you'll talk about next year in geometry. All right, guys, this is going to be your work. Give it your best shot. Do it on a separate piece of paper. And if you got questions, reach out. If not, peace out.